Okay, we have another example here that's going to cover similar triangles. So they're asking us to find the height of triangle DEF. So before we do that, I'm going to go ahead and make a note here that triangle ABC, so the first triangle, this one, is similar to triangle DEF. Okay, remember this little symbol means similar. So if they're similar, that means that corresponding sides have the same ratio as other corresponding sides. So we're going to go ahead and use that information and to find the height. So the height in this problem of triangle DEF would be this right here. It would be this piece right here. Okay, so if I go ahead and match things up, I'm going to do that using some color coding here. I can see that AC matches with DF. It corresponds to DF. Okay. And I'm going to set that equal to the height. So my height since I started with the smaller triangle first, and I have to keep the smaller one on the top. So this would be CH, okay, over FG. And FG is what I want. So FG is equal to the height, which is what I want, okay? So now we're just going to plug numbers in. AC is equal to 10 meters, okay? DF is 15 meters. And then CH is 7 meters. FG is what we don't know, so I'm just going to put an H there. Okay, and at this point, we can go ahead and do our cross multiplication. So I would have 10H. I'm going to go ahead and drop the meter for now. 10H is equal to 15 times 7. Okay, and I'm dropping the meter because I know that it's just a one-dimensional thing. So at the end, I'm just going to make sure you put your meters back. Okay, and then we would just solve. So at this point, I could say 10H equals 15 times 7, which would be, let's see, 7 times 5 is 35. 7 times 1, that would be 105. Okay, and then I would just divide both sides by 10. So H is going to be, let's see, 10 goes into 105 10 times with 5 remainder. So that would be 10.5, I believe. Okay, because 5 is half of 10. And it would be 10.5 meters. And you can double check in the calculator if you'd like. Okay, that's it. Easy as that. So with that in mind, we're going to go ahead and go over some postulates here that you might have seen in the past. And these are similarity postulates, okay? Not to be confused with the congruence ones, because those are going to come up right after, okay? So we have these three postulates that if triangles display these properties, that means that they are similar, okay? So if two triangles have two of their angles equal, so as long as two corresponding angles are equal, the triangles are similar, and this is known as the AA. I'm going to go ahead and put this symbol here so we know it means similarity, okay? If two triangles have two pairs of sides in the same ratio and the included angles are also equal, then the triangles are similar. So we're talking about two sides and the included angle. The included angle, just so you know what we're talking about here, would be the angle between. So you'd have a side and you'd have an angle and you have another side, something like that. And this is known as the side angle side similarity postulate. Okay. And last but not least, if two triangles have three pairs of sides in the same ratio, then the triangles are similar. So in this one, we're just talking about all three sides. If we have that proportion that we saw earlier for all three sides, then that means that they are similar triangles. Okay. So with that information, we're going to go ahead and do, I believe just one example, just so you can kind of see how this works. We have that, and actually it's a multi-layered problem because they actually want the area. So let's read it through. It says in the figure at the right, angle A and angle D are right angles. AB is equal to 10 centimeters, CD is 4 centimeters, and DO is 3 centimeters. Find the area of triangle AOB. So we need to find the area of this triangle right here. Okay, that's what we are looking for. So to find that, remember that the area is equal to 1/2 the base times the height. So in this triangle, this up here would be my base, right? And then this right here, just this piece right here, would be my height. So I need those two items to find the area of that triangle. So just keep that in mind. So what we're going to do first, we're going to go ahead and label everything. It says that angle A and angle D are right angles. So angle A is a right angle and angle D is a right angle. Okay? AB is equal to 10 centimeters. So it tells me that this piece up here is 10 centimeters, which also happens to be the base. Okay, I'm going to put that up there, just kind of hang out there. So this is 10 centimeters, and then CD is 4 meters. So CD is this bottom one. This one is 4 meters. DO is equal to 3 centimeters. So DO would be this piece right here. Okay, this is equal to 3 centimeters. Find the area of triangle AOB. So we need to find this piece right here, right? We need to find the height. We don't know what the height is right now for this piece. But if we can establish that these two triangles are similar, then we can go ahead and use our proportion to find the height and therefore plug it into the formula. So what we're going to do is we're going to see if these are similar by any of the postulates. Remember, you have angle angle, you have side angle side, and you have side side side. So let's just kind of go down the list here. Let's use this one. Angle, angle. So angle, angle means we'd have to have two corresponding angles. So angle A and angle D, those check out. So I do have one pair of angles so far. I don't know about this one, and I don't know about this one. So I really can't use that one. I can't use those. Okay, what about this angle here? What about this angle right here? Okay, do we know that those two are congruent? Well, if you remember from a previous lesson, when you have two lines intersecting like so, these are called the vertical angles. And they are congruent to each other. They're equal to each other. So we do in fact have the angle angle. So because we have that, we can say that triangle ABC, so ABC, I'm not sorry, not ABC, ABO is similar to triangle CDO. Okay, and now that we've established that, now we can go ahead and do our proportions. So I'm going to go ahead and do the proportions now, starting with AB. So I'm going to do this pretty quickly. So we have AB. So this piece up here corresponds to CD. Okay, and since I started with the bigger triangle, I'm going to continue. So I don't know what AO is, but that's what I'm looking for. So AO corresponds to DO. Okay, we're going to plug everything in now. So AB is 10, CD is 4. I don't know what AO is, so I'm just going to leave it as H because that's what I want it to be called, height. And then DO is 3. Okay, cross multiply. So we are left with 10 times 3 is equal to 4H. 10 times 3 is 30. 4H. Divide both sides by 4, which is going to give me approximately, so H is going to equal to 7.5 meters. So this right here is 7.5 meters. Okay. So that means I can go ahead and now plug all this in. I know all this work just for this. So I'm going to do 1/2 times my base, which was 10, okay, times 7.5. And if you multiply all this out, it's going to be 5. 10 divided by 2 is 5. 5 times 7.5 is going to give me, let's see, 37.5. So I'm getting 37.5 meters squared. All of that work for that one problem. Okay. And that's how you would do a multi-layered problem like this one. All right, let's go ahead and move on. We're going to start talking about congruence now. So congruence is pretty much everything is the same. So the sides are the same, the angles are the same, they have the same shape and the same size. And just like we had postulates for similarity, we have postulates for congruence as well. Not to be confused. So this one also has a side, but this is congruency. So that means that it's not just the sides that are the same, but the angles are also the same. And you can see that here in this example, okay? If you look at the triangles, they look like one of them's kind of flipped over, but you can see that you have a match for each one. So the fives are there, the six, okay? And they look to be about the same size, okay? So this is our example of a side triangle. You have each corresponding side matching another one. Side angle side. So this one, again, not to be confused with the one before, is a congruence postulate where the sides are exactly the same. So it's not the proportion anymore, it's the actual measure. So this is 7, this is also 7, okay? And this is 4, and this is also 4. And the included angle is equivalent. So 120, 120. Okay, so it follows this pattern of side angle side. And again, this is different from similarity because the similarity postulate means that the proportions are the same. So the ratio, we multiply it out or divide it, whatever, they come out the same. This one, there's no dividing, multiplying, it's just the same. Okay. And last but not least, we have angle side angles. So angle side angle, like the one before, has two angles that are congruent, okay, and one side that's right in the middle, in this case, this 9 feet here, that is the same. So it kind of follows like a you'll see something like this, okay, where you have angle, angle, the side in the middle is going to be the one that's congruent, okay? So with those three, we're going to do a couple of examples. We have given triangle LMN and triangle QRS. Do the conditions, all of this, okay? Guarantee that triangle LMN is congruent to triangle QRS. If they are congruent, by what theorem are they congruent? So you are going to have one like this. So what I recommend you do, and I'm going to be looking for that, is to first draw the triangle. So we're going to have triangle LMN and triangle QRS. So QRS. And you want to go in the order that they give you. So LMN needs to follow QRS. Okay. We are given that angle M is equal to angle S. So angle M is this one. So I'm going to match it to angle S. Okay. Angle N, so I'm going to put two curves for this one, is equal to angle Q. Okay. And angle L, so this one, is equal to angle R. Okay. So let's go ahead, and that's all we have. So this looks like you kind of have like an angle, angle, angle thing going on, A, okay? And I do remember that we had an angle, angle postulate before with similarity, but we're not talking about similarity, we're talking about congruence. So let's go ahead and look at our congruent postulates again. We have angle, side, and, sorry, did I skip one? Side angle side, sorry, and side. So none of those three has just three A's. So that means that no, they're not necessarily congruent. So not necessarily would be our answer. And this picture is our proof. Okay, let's try another one. It says given triangles PQR, so we're going to just jump right into it. So here is PQR and MNO. So here is MNO. Okay. Do the conditions angle P equals angle O, so here's angle P is equal to the measure of angle O, measure angle Q is equal to measure angle M, and PQ is equal to MO. So I'm going to do that in a different color just so we can see. So PQ, so that's this piece right here. So that piece is equal to this piece right here. Does this guarantee that the triangles are congruent? Well, let's see. It looks like we have angle, angle, so those match. Then we have a side, then we have a side, and then we have an angle here and an angle here. So I'm seeing angle, side, angle. And if you remember from our postulates that we did a little bit, a minute or two ago, this is in fact one of the congruency postulates. So yes, they are congruent by angle, side, angle. Okay, easy as that. And I think we are almost done. We just need to cover one more property, a very, very well-known property of triangles, and that is the Pythagorean theorem. See, I'm almost out of space here. So I am 99% sure that you know that you've seen the Pythagorean theorem at least once in your life. And this is a theorem that is super popular. I actually wanted to do a project with this, but fortunately for you all, we don't have the time. So, if this was a full term semester, we would definitely be doing some more research and interesting things with this theorem. But anyway, we have that if A and B are the lengths of the legs of a right triangle, and C is the length of the hypotenuse, then C squared is equal to A squared plus B squared. So just to kind of remind us, because I know it's been a while, maybe for some of us, hopefully your triangle is better than that, but actually that's a little bit too extreme. A right triangle has two legs, okay? This is a leg, this is a leg, a right angle, that's why it's called a right triangle, and then it has a hypotenuse, which is always across the right angle, and it's also the longest side in the triangle, okay? So just remember that. So this is saying that A and B are the legs. So this would be A, this would be B. You can swap it doesn't matter. And this is your C, okay? So in the example that we have here we're given, we have that A is 5, B is 12, and we don't know what C is. So you just plug it in, A squared plus B squared equals C squared, which gives us 5 squared plus 12 squared, 25 plus 144, 169. To get the opposite of a square is a square root. Square root that, we get 13. And we're only looking at the positive roots because distance cannot be negative. So I know that in other classes you might have said, well, the square root of this, okay, is going to be plus or minus 13. But we don't want to do the minus because that would give us a negative number and that would not make sense in this problem. Okay, so just one more example that deals with Pythagorean theorem going the other way. Okay, so in this case, we're going to look for x, which is one of our legs. Okay, so just to kind of set the problem up, remember that a squared plus b squared is equal to c squared. And in this problem, it looks like we have a, we don't have b, which would be our x, okay, and we have c. So I would plug in whatever I do have first, so that would be 10 squared, okay, plus b squared, which I don't know what b squared is. So I'm just going to you can use b or x. I'm going to go ahead and just use x because I put that first, but it doesn't matter. And then c squared is our 15 squared. Okay, then just, work it out. So 10 squared is 100 plus, we don't know what x squared is. That's what we're looking for. We'll just leave it that color. 15 squared is 225. Okay, solve. So we would subtract 100 from both sides. So x squared is equal to 225 minus 100 is 125. And then our last step here would be to square root it. So square root both sides. Remember that we just want the positive square root of that, and I don't know what that is, so let me calculate it real quick. Square root of 125 is approximately 11.1. We'll just do 1/8. And it's approximate, so we're not gonna put an equal sign there. That means approximate. 11.18 feet. And that's it. If you have any questions about any of this, as always, let me know.